So I want to introduce David Gross. He doesn't really need an introduction at this institute. David is a permanent member here on the faculty, and prior to that was the director for 15 years. Is responsible for a lot of what you see and experience in this building, including the Teachers Conference. Somebody asked me today if there were any Nobel Prize winners here, and I said, yes, indeed, David Gross is a Nobel Prize winner. So somebody's going to want to shake your hand, David, because apparently they collect handshakes from Nobel Prize winners. David received the Nobel Prize for his work in QCD, quantum chromodynamics, and I was here when the event happened. It was a very fun day, and I think David's life has been fun before and after that event. So while we're getting set up, and David is presently, the reason he's really giving this spiel is that he is this year the president of the American Physical Society, which for all of us practicing physicists is our professional organization. So David.
Well, anyway, it's great to be back at the Teachers Conference. Right. This is now, and I recognize some of the faces here. This is the 20th anniversary of this conference that we established way back 20 years ago. And some people here were back. So who of you were here 20 years ago? Wow, that's remarkable. And of those, how many of you have been here every year for 20 years? But you're local. Anyway, so we have a lot of very loyal or smart participants. So I'm this year the president of the APS, and as president, I've been involved as vice president, president-elect for the last few years, and I've learned a lot about what the APS is doing to promote physics and help would-be physicists and physicists and so on. A really remarkable set of programs, which some of you I'm sure are aware of, like PhysTech. How many of you are aware and benefit from PhysTech? Not enough. Okay. One of the most interesting new initiatives is Step Up for Women. So it turns out, and I'm sure I hope you're all aware of this, and Justin is going to provide the actual some crude data that we have. The bottleneck for women participation in physics, not STEM, but physics, is high school. As Justin will show, that's where the bottleneck is. As far as in high school, from what figures that we have and the American Institute for Physics collects, participation in STEM classes of women is about equal in physics, chemistry, biology. The big difference is then the transition from high school to college, where the number who go into undergraduate majors in physics drops from 50% participation in high school classes to 20%. And then it remains roughly constant throughout one's career, which is a remarkable achievement, actually, of the efforts that have been going on throughout the United States and universities promoting diversity, keeping that 20% roughly flat. Now, this is 20% participation when the number of students going into STEM and into physics in college has increased dramatically in the last 10, 20 years. So our efforts at promoting science, mathematics, engineering have worked. So the number of women as well has increased dramatically, but not relative to men. And the bottleneck appears to be in high school. So that's why you guys are so important. Now, I'm going to turn this over now to Justin, who is one of the volunteers, right?
Mm-hmm.
and ambassadors for Step Up for Women, and can tell you in great detail about his experiences and about the curriculum activities that we're trying at APS to promote, to try to change this in a dramatic fashion. And this is definitely something that those of you who are teaching, or even those of you who are retired from teaching, can contribute to in a big way. And Justin will tell you how as well. But first, let me introduce Justin Fournier, who is a teacher at Cypress High School in Anaheim. Not just any teacher, he was last year Phys-Tech Teacher of the Year, which is an award given by Phys-Tech, which you should, it's not here, but
thanks, Phys-Tech.
And Step Up for 4 really has come out of that experience. So after Justin gives his spiel and inspires you all, we're going to have a short discussion period. I really would be very interested in your feedback to this presentation, to the whole idea, to your understanding of why we have this bottleneck, specifically in physics and specifically at the high school level, and what APS or other organizations could do, what you think would work, and why do you think we have this bottleneck. So we'll talk after Justin. Justin?
All right. Thank you. Hi. Yeah. Hello. Yes. So I'm Justin Fournier. I'm here to talk to you guys about Step Up for Women. So I'm about encouraging more diversity in physics majors, particularly for the case of women. And hey, who to tell you about diversity more than a white suburban guy from Detroit, right? Yeah, I'm the essence of diversity right here. So, but yes, when I went into teaching and teaching physics, I said to myself, I want to encourage, I want to excite kids, get kids excited about science, get them excited about physics, and encourage them to pursue careers in science and physics in particular. And I as a goal, I do want to see more women in physics fields. And so when my colleague, actually, who's also a physics teacher, came to me and he said that he was doing this thing, I said, oh my gosh, I want in. So I've implemented, this is my second year now implementing this thing. They kind of tested it, modified it for this year. So I just finished up this year teaching that with them. And so I'm going to kind of book it through this thing because this was an hour-long presentation that I've dialed down a bit. So I apologize if I'm going too fast or anything like that. If anybody wants me to slow down or anything. And these slides, I'm being told, are going to be uploaded to that website and everything. So, okay, here we go. Here we go. There we go. Hey, that's me. There we go. Good for me. Okay, so we got a bunch of data here. And there's W, X, Y, and Z. So talk to your neighbor, and we're going to have a show of fingers here. Which country has, and these are, percentage undergraduate physics degrees awarded to women. So this is the percentage of undergraduate physics degree awarded to women. So we got 60%, 50, 34, 32, 24, 22, blah, blah, blah. So what country do you think is W? Is it Germany, India, Iran, or USA? Which country is Z, et cetera, et cetera. So we'll, and if you think it's Germany, you're going to hold up a 1, India a 2, Iran a 3, and USA 4. So quick little discussion here. Not going to give you too much time. About 10 more seconds. All right. So, for people who think country W, let's go. Country W, just hold up your fingers. Germany, India, Iran, or USA. Country W. country W. All right, let's see. 1, 2, 3, 4, 5. Well, okay, we'll just go with what I'm going to book it through here. Okay, we got country W, you got your prediction. Country X, I'm sorry, who thinks country Z? Country Z, what do we think for country Z? Hold that up. All right, okay. Country Y, who's got the 20%? Country Y. All right, okay, and then country Z. What do you think is country Z? The very last. Oh, I'm sorry. Yes, sorry. X, Y. Yeah. Sorry. So, okay. All right. Well, here we go. Here's the results. We're not last. We're not last. Way to go, us. Oh my goodness. Wow. Once again, source is right here. That'll be posted up there if you want to look at that. But Iran ends up graduating 60% of their people who are graduating are women. India has a 50-50, and USA and Germany 20 and 19%. And so obviously that's not acceptable. What we realize in looking at this data here is percentage of students who are women at various academic stages. So percentage of students, and these are physics, chemistry, and biology. You can see a little bit lower right here in high school, but still, reaching about that 50% mark. And what do you guys notice happens between high school and college? Huge drop, right? Huge drop compared to chemistry and biology, which, fluctuating a little bit there. But, this was the plan of attack then here for this curriculum, was basically go, okay, something's happening here, and we need to focus there. So the focus of this curriculum that I'm going to share with you has a lot to do with, is focused on high school. All right, so, yep. Women physicists become interested at this time compared to elementary school. Teachers have greater content knowledge and are more vested in physics, and students are closer in decision making and time for their majors. But compared to college, typically your introductory physics college course is going to be a huge lecture hall. So in high school you have smaller class sizes. There's opportunity to build more relationships. STEP UP, that's what it stands for, supporting teachers to encourage the pursuit of undergraduate physics for women. Gotta love acronyms. And the goals here is, yes, to dramatically increase the number of young women pursuing bachelor's degree in physics in the U.S. and shift this deep-seated cultural view about women, about people who do physics. In cooperative effort with all those institutions there. It's got 3 parts to it. The first part to it is basically an everyday actions guide. What can you do as a teacher every day to help support or encourage women to pursue a degree in physics? And I'll talk a little more about that in a bit. The next thing, and this is the big crux of what I'm going to talk about, is the careers in physics lesson. That's the first lesson. And then the second lesson is the women in physics lesson. So careers in physics explores what kind of career opportunities you can have as a physicist or a person with a physics bachelor's degree. And then the women in physics lesson actually confronts head-on what are the issues, what are the barriers that women are facing that is causing that huge transition from a high school rate to a university rate. Everyday action guide. What I like about the way it's basically like not a pamphlet, but like a packet of sorts. But what I like about it is, oftentimes teachers will get packets and they'll go, wow, this is a big thing. I'm not going to read all this. No way am I going to read all this. If you want to read all of it, you definitely can. But what it does is at the beginning, you take a little quiz where you analyze yourself. And based off that quiz, it says, hey, why don't you look at this page? Why don't you look at this page? Why don't you check out this? Here's something little that you can do, every day to then, it's basically research-based and usable in every day of the classroom. compiled into an everyday actions guide, ways that you can talk to students individually, how to set up group work in labs, address the whole class, plan and assess, and promote physics outside of the classroom. And it's kind of set up like this. Something that definitely is something that I did not know to do is research shows that if you are putting students into lab groups, you either should do 50% women, 50% men, or do majority women and less men, because if it ends up being majority of boys, they tend to dominate the thing. They're the ones messing with the lab equipment and stuff like that. That tends to be the case, and that's what research shows. So that's how I set up my classroom now. It's either going to be 50% girls in a group or majority girls in a group. So yeah. So ways to address the whole class. Sometimes I'll notice when calling on students that, a lot of boys are raising their hands, so I'll call on a girl to see, what's her input and stuff like that, so that students can see I'm, randomly choosing between students to answer questions. And yeah. And so, yeah, more stuff even outside the classroom. And if you want more depth into the research, there's also parts to this packet that gives you justification for why you're doing what you're doing, as well as other teachers' experiences or tips that they've done right there. So that's the everyday actions right there. So next up, the big crux of what I'm going to tell you about is the careers in physics lesson. So the careers in physics lesson starts off with a prompt. Name a career you can have with a bachelor's physics degree. Many ways you can do this. You could use like a poll everywhere or something like that. Anybody ever use the site poll everywhere? Yeah. That's really nice because they put up like a word map on there. Other ways you can do it, more old school, is to use like Post-its, have them write, a few Post-its of things you can see. Here's an example from another conference, though, so you get a bit. But what you tend to get is physics teacher, scientist, and engineer shows up, NASA worker. I don't know why Fortnite is here. You can be a player, apparently. Yeah. So lots of things with rockets and NASA and everything. Yeah. They have a very limited idea of what a physics degree can get you. And then basically then they complete this survey. It's 2 questions, so pretty easy. And then you use this profile matching matrix. It looks intimidating. I'm telling you, it's not intimidating. So hold up. Let me show you what it looks like. So these are the 2 questions right here. It's 2 areas you are most interested in. 2 areas I'm most interested in. Oh, I don't know. I'm interested in chemistry and physics. And so mark 3 important factors for your future career and satisfaction. Well, I want to help other people. I want to have job security. I'm a product of that economy crash, so I want to keep my job. Working with people. Yeah, I want to work with people. That sounds like a good thing. And then what you do, so I got B, C, and D. And then I got B, C, D. There we go. And so C and D, so that was question 1. So question 1, here's all the column for question 1. And here's the column for question 2. So question 1, what I tend to do is I give them colored pencils or something like that. You can use highlighters, you can use anything you want. So C and D was my first one. So it seems like I got a lot of C or a lot of D's here. So there we go. I highlighted that. And then what was it? B, C, D, I think the other one was. So this is B, C, D. So I'm going to go down, and here's where they match here. So it looks like Kate Shaw might be my person, and Nashwa Essa, yes, possibly. So then they go and let's go back to this thing here, slideshow, current slide. Nailed it. All right. So now. basically what they, let me go over, show you what it is. They get these, they basically, what they're assigned is a person. And this is a real person with a bachelor's physics degree and what their career is, and gives a little summary of their career. And if they want to know more information, they can go to that website right there. Some teachers have done it where they just show them the PDF and they got to just, click through and find out who it is. What I tend to like to do, I've cut out all of them. And multiple about like 3 or 4, and then I'll put them in alphabetical order all around a table, so that when they go, they have to grab it and hold on to it, so that this is their physicist now. This is who they have. And then they, So, gonna go back here, and then they have to answer questions. What does your physicist personally value about their degree or career? Who benefits from their work, and what did they gain from their physics degree? And one of the reasons for these kinds of questions is because women, when they talk about a career that they want, they often are looking for things that they personally value about it, that they're benefiting to society, and that they're gaining from what it is that they do. So, all right. So, and then. After the discussion, we talk about what new careers emerged from researching their physicist profile. So, what kind of new careers did they see? They share with each other. Some students will share with the class. I've had some kids like so excited about their person that they can't wait to talk about how awesome this person is. So yeah, and then we go and do this one more time, and you get a much more broader list of types of careers you can have. With physics. Yeah. And then we go into, now I tend to do this part a little bit later. I go into the research, but I'll tell you what this is. They fill out this thing. I want to pursue what's your dream career, basically. I want to pursue a career in this. In this career, I will focus on yada, yada, yada. What do you hope to accomplish or contribute by pursuing this career? And how can a degree in physics lead you into this career or support your growth in this career? So that comes as a worksheet or a handout. So I've got stuff if people want to. Those are examples that I'll show later. That's me. That's my example. But here are actual student examples. But I have some stuff right now. I'll tell you how you can get information on this. So these questions are on a worksheet that they can use. And then they develop a personal profile. Some teachers do this within one period or couple periods. I tend to do it as a homework assignment, something that I want them to work on. So it's basically they undergo like a kind of a thought experiment. They go, okay, I'm in my dream career, and I have a physics degree. It's in the future. I'm in my dream career, and I have a physics degree. So they are visualizing themselves in their career with a physics degree and doing the same thing as what they've read these people do here. So they're seeing themselves in the shoes of a physicist. So they have a picture. It used to be just any kind of picture you could put in, but we kind of decided over the summer this year. I really like the idea of you put a picture of you up there. It is you there. And so they say who they are. So, who are they? Why physics? Why did they choose physics? Using physics, how do they use physics in their career or their daily lives? And advice for students, for future students in the future. And so, again, I got examples here. Let me just kind of quickly show you some examples that I got here. So, I share with them my own. I share with them my own, and I read it for them so they have an example of what one looks like. But, we got forensic chemists, aerospace engineers, medical physicists, aerospace engineer, structural engineer, biomedical engineer, lots of engineers, civil engineer, wow, lots of civil engineers, aerospace engineer, wow, video game designer, there we go, there's something a little different, forensic scientists, and business development. So my favorite is when they crudely put their face on top of a, that's always a good one. And I got physical copies of these too if you want to look at them. How much time am I at right now? Where should I? Oh, 10, 15? Okay. Is that?
Yeah, we're going to lunch will be a little bit.
Okay. All right.
I don't know how much more you.
Please don't hate me for stomping on lunch, for ruining lunches. Okay. So, yeah, but I tend to forego that activity first. I show them this data, and then, like I said, I make the profile thing, a homework assignment that they turn in, that they take a little while to work on and make them look all pretty and good and everything. Yeah. So, but we then show them some of this data too, based on national surveys. So what people with physics degrees, they tend to have a 95% of, so high employment rates, 95%. That's pretty good job security, yeah. High job satisfaction, 71 to 93%. I mean, how many people go to work and go, I love my job? I'm one of those people, yeah. So, and then the job opportunities you have. I mean, there's a huge range here of what these people do, and they all have physics degrees. AP especially loves this one because you go, anybody know what an MCAT is? And they're like, oh, I'm gonna get I'm gonna nail that quiz. I'm gonna be so good at it, yeah. And then you show them, well, here's a list of majors and their scores on the MCATs, and physics just below economics. But okay, fine. So physics is there, and now this isn't the bottom level, but this is just kind of where the cutoff was. What's funny, sorry for anybody who's a bio major. So and then you got what about an LSAT? Oh yeah, I'm interested in taking the LSATs. Well, here's how you do. Here's how majors do with the LSATs. Once again, physics just 0.1 behind those rotten math majors. But then, here again, this is just a cutoff. It isn't at the bottom, but, sorry. And then, if you tell them, hey, if you're just in for that, that money, look at that right up there, top of the list there, kind of a broad range, but definitely physicists, these are starting salaries, I think. So, comparatively higher starting salaries there. And then, we show kind of the different areas, so physics, classical mechanics, electromagnets, quantum, thermo, and lab and math skills of the types of careers you can have and the reason that physics tends to be so broad and do so well. And what we've seen, so we did surveys with our students, and what we ended up finding is that no matter what, there was a gain. There was a gain in students who were interested in physics, and a greater gain of about 7.5%, more or less, for women. So overall gains, though, overall positive, which, hey, awesome. So here's just some quotes of other teachers who have done this. Again, we were kind of like pilot teachers. We were piloting the curriculum. Students don't realize all the things that they can do with a physics degree. It helps students to see that physicists can help the world and work with others. The poster student makes as a part of the lesson help recognize students and who they are. And as a student, I wish I had the opportunity of envisioning my future with physics. Another thing that I really like about this is this is going to be now like a beginning lesson for me, because it's a great way to introduce myself and me to get to know the students as well, what they're interested in, how, well, yeah. So the second lesson comes a little later in the year. I tend to do it either at the end of the first semester or with my regular physics. I did it at the beginning of the second semester. But it's a women in physics lesson. So it's directly confronting this idea that clearly there's an issue with female representation of physics in physics. Big thing that we talk about are, a lot of girls will feel like, oh, I can't do physics. It's not for me. Everybody's better than me than I am. And one thing I love to do, well, we show data that's actually been researched, but I love to post my most recent test scores. And I'll go, here's all the boys did, here's all the girls did. So far, both years that I've posted it, the girls did better, but it's always like one question better. Like, oh, if you would have selected the other one. But other times I've seen it. It slightly fluctuates up and down. I mean, there's no difference. So giving girls that feeling of, oh, wait, okay, maybe I am good at this. And so, yes, this tends to create good discussion. It's in general good discussion. Every once in a while, you'll get some. You'll get somebody who says something like, "Oh crap, I shouldn't have said that," type of thing. I'll give you a quick example. But we make sure we got these. Let me make them bigger here. We got these kind of rules before we talk about it. You share your time equally. You value differences. Own your impact. Make sure everyone feels safe. Discomfort is okay, and argue using evidence. But I remember one time doing this, and I had one kid say something. He was trying to be funny, but it clearly came off as offensive. And I remember going, "Oh, great! Now, like this is why I love my numbers. I didn't have to deal with this, type of stuff. Like I want to do equations, and I'm like, I'm gonna have to say something now, But sure enough, what ended up happening is basically all the girls in the class just boom, 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 boom. It didn't attack him physically or anything, but basically shot him down. And you could see the look on his face, like, oh, that was the stupid thing to say. Like, I'm not doing that again. And even later on in the class, ended up saying something a little more, took the thing a little more seriously. So when I'm going to gloss over this lesson because the big thing was on the first lesson. But basically, you start off the lesson with Google famous physicists, and sure enough, what can you expect? It's all these dudes, right? You get the eventual token Mary Curie there, right? Often, yeah, all old dead white dudes and Mary Curie, and that's it. That's all the physicists. Yes. And then we show more data and graphs. Here's one of them right here. Right, the gain of women with physics, with science bachelor's degrees, all here. And I mean, engineering needs to step up their game as well. But this is not acceptable. I personally feel like, where things like biology is looking good, chemistry even not bad. Math and stats has a little way to go, but. So we share data, we talk about the data, and we talk about what do we think the reasons are here. But again, that's the Everyday Actions Guide, Careers in Physics lesson, and Women in Physics lesson, and includes a classroom poster. So basically the idea here is what you're going to do. We are now that we've started with the pilot teachers, we are going to we want now to blow this up, to have, as many physics teachers, or all physics teachers, all physics high school teachers, implementing this curriculum to try and really push to get more women in as physics majors. So they want, though, we are looking, though, to make sure that we're getting actual data to show, yes, this is improving. We are, reaching our goals. And so to do that, we ask that you go to Step Up for Women. Step Up for Women. So if you're not typing that in right now, or you can take a screenshot right now, or something like that. I know this will be posted up there soon, but you'll go home and go, oh, I'll do it tomorrow. Blah, blah, blah. But you go to stepupforwomen.org and sign up. So you just register there. What happens is it's a newsletter. I think it's a monthly newsletter. And every time they post the newsletter, the updated versions of Everyday Actions, the first lesson and the second lesson are there. So they're attached to the newsletter. So that's what you should be expecting. If you want it sooner, you can even email them, and I'll show you who to email here, and they will. I've been told they will give you the stuff. Yes, so it comes with PowerPoints. Printouts like I have here. Again, if you want just some printouts and stuff, I can give you those. I'm gonna book it here. So I hope you took a photo or something, because it's gonna cut away. Oh shoot! Provide feedback. Tell us how it went. So if you're also interested in being an ambassador, so that's kind of similar things to what I'm doing right now. So And compensation and recognition. Wow. Let's see. Due February 2019. So it's coming soon. So, and if you're interested in doing that, that's Bree's email right there. You can talk to her. Sorry, so other than that, if you want to evaluate, those are those links right there. So you can go to the links or the what the heck are those codes called? QR codes. Here's my email address if you want to email me or ask me anything. But I'll be here the rest of the day as well. So if you have any questions there, I'll be there. And I'm going to shut up now. And yes.
I'm thinking that March is
Sorry. Thank you. Sorry, yes.
I'm thinking that March is Women's History Month.
Yes.
I'm thinking that March is Women's History Month, and this will be a great activity to bring into the classroom for that month.
Yeah. That sounds like a great idea.
So let's thank Justin again. I mean, you can see why he's an award-winning teacher.
Thank you.
So I hope he's convinced you to join in this program. The program is, there are something like 17,000 physics teachers across the country. This program is aiming to enroll something like 500 or so. But they're very ambitious. As Justin explained, this is a dialogue. The curriculum will continue to change. It will be feedback and measurement. They want to make a measurable difference over a 5-year period. In fact, they dream of raising that 20% to 50%. The numbers are quite simple. If every teacher who gets involved in this encourages one extra woman undergraduate, that will reach 50%. So one can really make a difference here, and the program hopes that it will, and it will be both measurable and verified, and have a noticeable impact. Anyway, and Justin will take questions now, but not so much questions. I would like to hear comments on how you understand the bottleneck, what you found useful in trying to encourage women to go into physics in college, and your comments and reaction to step up for women. So we need mics.
Here's the mic.
This is one mic.
There's another one.
Where's the other one?
Hi. First of all, thank you for your presentation.
Thank you.
I teach all girls in New York City, and one of the comments that they have made, we've had a lot of discussions about this, is they do not like the notion that there's a gender gap in STEM and that they're reminded of that constantly. They feel that it victimizes them, and to them, and I'm only speaking for my students, that for them the most important thing is encouragement and sustainability. And so the work that we've done in our school is to provide more opportunities for the students to network with people in all the STEM fields. And they also have the belief too that it's important for men to be part of the conversation. So one of the projects that I have my students do is that they interview physicists. They have to do their own research, find someone they want to interview. Man or woman, it's up to them. But then building networks and starting to build professional networks when they're in high school about people in the field that they're interested in. So for example, all of our students have their own LinkedIn page, and that's how they start to build those networks. So I think what you're doing is really, really good, and I'd like to see, I'd like to become part of it as well. But the gender gap is really the one thing that bothers my students the most. that they're continually reminded of that. So thank you.
So I'm actually curious if you're aware of American Institute of Physics Center for the History of Physics. They have teaching guides that it's a project I actually worked on as an intern over the summer. And what we did was we edited and created lesson plans on the history of women and minorities in physics. And we created different lessons. Some of them were physics, some of them were math, some of them were history, where we looked at like the different aspects of it. And I just was curious if you knew about it, because APS is part of AIP, and it's all online, and you should totally go talk to Greg Good, because he's the one who headed that up.
I am not familiar with it. Can you say that to me one more time?
Yeah, the American Institute of Physics Center for the History of Physics. Their webpage, if you go to the left-hand side, there's a little link that's teaching guides on women and minorities in the physical sciences. And there's, I think we had close to 100 different lessons, some large number. It had been worked on over a number of years by a number of different interns.
How many have heard of the AIP history?
Okay, cool. That's awesome. I'm so glad you guys know about it.
It's nice that there is 10%.
Yeah.
But 10%. So one of the problems you guys face is there's so much out there, right? And you just don't know about it. And that's what that's one of the problems. It's nice that there's some.
Just thought I'd let you guys know about those resources. So.
Thank you.
I was going to agree with what he said from his student's perspective. One of the things that turned me off, I was a dual major, bio and physics originally, and one of the things that kept me from pursuing physics to a higher level was comments made by professors that you could write your own ticket because you're a woman. So the insult level, and then they'd point at faculty. You know, look at so-and-so, she got hired. So avoiding the either because of or in spite of comment, and just the general encouragement, and we have some pretty good programs in San Diego where the local colleges put on, labs and things and invite high school students, and just to make sure that women are included in that. But that things that are geared specifically towards, you're a woman, you should go into physics, is kind of a put down. And I had a student that went to Stanford who left physics because in some of her first jobs, when a male colleague wasn't present, they would say, well, should we reschedule, So there was still a lot of sexism in the industry.
So you're saying that women, young women resent being classified as a problem, or their career choices as an issue, but it is an issue. So how do you? I'm very interested, and I've asked young women as well. APS also does a marvelous program called Conferences on Women in Physics, which brings together. Just had 12 conferences around the country with over 2,000 young undergraduates, and this program was presented to them by, and I talked to some of the women and tried to understand why is there a bottleneck? So I'm puzzled a bit by this reaction. Are they not aware of the bottleneck
No, they're aware.
but they would what? So
Well, like for example, I was interested in physics because my grandpa worked at Hughes. My father was a physics major. So to assume that paths are going to open for me because I'm a woman,
No, I
as
don't
opposed
think-
as opposed to because
well,
I'm
that's
interested in
certainly not
physics
the
and all
purpose
that.
of
No. I'm not saying it was.
Yeah.
I'm just saying a lot of times that's the perception
I
from
see.
girls is that you're trying to, in your encouragement of me in this field, you're also making it seem like I'm less capable. So if you can just do the encouragement of me and of everyone in this field, and honestly, I don't know, I was always interested in physics,
Yeah.
so I don't know why there wouldn't be that interest. So it might just be a lack of people at younger levels encouraging.
No, the figures, as Justin showed, of participation in physics classes
In
is
physics
roughly
classes,
this.
yes, but you require a certain number of years of science and they want to get into college. So of the girls that are in the physics classes, are they in the high school physics classes with the intent of studying physics or with a different intent?
Well, there's a drop, clear. I mean, 50% participation obviously doesn't mean 50% majors in universities and colleges. But the difference between physics and chemistry and biology is quite evident. It's a big drop after high school. And that is coming from where? The culture is coming from elementary school, it's coming from their peers, it's coming from their teachers. I don't think we truly understand it. But you're saying that young girls don't recognize that there's an issue and they feel offended by being classified as a problem.
They recognize that there's an issue. They're offended by being constantly reminded of the issue as if they're the solution.
I see. Okay.
So I think part of it is a difference in perspective when the students come into my class. And I speak of this not only teaching a lot of different students, but my own son and daughter. My son went into physics, my daughter went into a biology-related career. And believe me, they had the same, let's say, encouragement at home in both areas. But I find that the perspective of my students, male and female, is a little bit different. First of all, as to what is doing well in a class. The female students very often look at, if they're not 100% sure of how to solve for an answer, they don't think they're very good at it. And I don't know, but I've never been really 100% sure of any physics problem I've solved. So, so they feel like they're not very good at it there. And where the blame goes if they do miss something, I ask them questions after every test. I have a little survey sheet, and the girls tend to blame themselves more, and the boys will blame me or the test or something else.
Yep.
And I'm not saying across the board, but in general, I see that. And so even if the scores are higher, the girls don't think they're as good at it. And it's more difficult, but I don't know. I think maybe it happens before they get there, before they get to the high school level.
So I wanted to say you had said something about grouping, and I always put my kids in 100% gender-specific groups because boys and girls work so differently. There is a fundamental difference between boys and girls. When you give boys lab equipment and say go, they don't read the directions. They play with the thing until they get it. Where girls haven't touched it in the first half hour, they've carefully read all of the steps. And they get to the same point at about the same time, but they've come completely different paths to get there. And I think that because girls take that other path, that they don't feel as comfortable with physics as they do with biology or chemistry.
They don't have as much fun.
Right, and I didn't like physics. I didn't even take physics in high school. And it took me years to come back to physics because there was nothing cute or fluffy, nothing that grew. It was like cars and gears and rubber bands. Why was I interested in that? I think there are some just fundamental differences between boys and girls. And I love girls to take physics, but they might just not be into it.
Okay. I just think it's a global problem in terms of our expectations for my daughter versus if I have a son. I think that's our society. It's been that way for a long time, and we're making improvements on it. With my students, the girls are always the one who are kicking ass, and they pretty much outperform my boys almost always. Not always, but I've had some really exceptional students. I think what we need to do, well, first off, you need to understand you're running against CSI and all this other stuff. It's biology, and chemistry, and they see it. I can't tell you how many students want to be forensic scientists, right? Because they see it on TV and it looks really cool. Okay, but we have in California, teachers, they have what are called California Partnership Academies, and it's a school within a school, and so we have a STEM academy within our school, and it's energy and utilities. Because I live in an area big in oil and stuff like that, and wind power, and so we get them in that way with just doing STEM, and then in physics, I think it's up to me and up to our other teachers to get them interested in a STEM. We have I want to say 70 or 80 community mentors who mentor them once a month. They work for Chevron, ERA. If PG&E still is in existence, they work for PG&E, universities, stuff like that. And they come in and talk to them every month about, what are the careers, what you can do. And I think that's the key point what you were talking about. It's like no one knows what a physicist does. Just like, what does an engineer do?
Right.
I don't know. How about a chemist? I don't know. What does a chemist do? And I try to get them to say, you can do anything you want. I mean, it's a wide range, but we don't know that, which is why I like that. I think if you're in California, your district is amenable to doing a California Partnership Academy, it's a good way to get kids into that program. And you get extra money, so you actually get to go on field trips. I've been to Diablo Canyon, we go all over the place. And it gets kids in general, but a decent portion of them are women. And a decent portion of those go on to be physics majors, engineering majors, chemistry majors, biology majors. So if you have access to that, you should check into it.
Thank you.
Is it lunch yet?
I teach in New York. So in high school, because of the Danielson, so teachers always encourage the students to participate. So we don't really have that issue, girls or boys. But it's my personal experience when you go to college, there's a disconnect. Because like in New York, now I'm taking a class just for fun, for teachers who want to, and it's graduate class. It's physical science. We're just doing experiment and talking about, teaching practices and stuff like that. But then what I observe is, in my group, we have 3 female teachers, or in service teacher, and then 1 male. The professor always come to ask the guy, while we 3 male teachers, or me especially, have a lot of ideas. We got the answers and stuff like that. But when he comes to us, he always asks that guy. It's like he's the only person who can answer the question.
Have you told him?
So
Have you told him that?
That's the perception, okay, he can answer the question, while Asian or minor or female couldn't answer it. So I think it's how you change the perception, because for college professors, they don't have to answer to those questions, or class participation, everybody got a voice, that type of thing. They just do whatever they have to do. And then I'm thinking should I go and talk to him? It's I can answer the question too. You should come and ask me what I think.
I think you should have a conversation with him.
I was going to say, I like your numbers as far as the high school. I'd be thrilled to have a high school class that was remotely close to half girls, half guys. For about 15 years, I taught physics, and I was typically the only female in the room. A lot of times I'd have 1. If I were lucky, I'd have 2. The other thing that I would say when looking at your statistics comparing physics to chemistry and biology, when I think physics, I think math. Of course, that's my first love. So, but I would, instead of comparing what those numbers are to chemistry and biology, I wonder if that's the same thing with math, because I think that's more of the same field whenever I think with physics. And, of course, you also present to NSF what's going to get you funded as well. I'm glad you're doing it. I like this, and I'm going to share this. Thank you very much.
Thank you.
The math, I think, in high school are probably the same. After high school, math does better, as you remember from his numbers on gender diversity. 30% compared to 20% in physics and astronomy and engineering. So the relative percentage of women doing physics is stuck at 20% for the last decade. And of course, the numbers have increased. The overall numbers of boys and girls, men and women. But 20% is stuck. What is reassuring for us at the universities is that it's not a curve downwards after college. That, affirmative action, family leaves, maternity leaves, et cetera, all these things have worked. So instead of, it used to be declining, it now is constant across graduate school, faculty, jobs. So universities have actually succeeded in keeping it constant. But the problem is the input. So whatever we do at the colleges, university level is not going to do much good if the input remains at this 20% level. And that is specific to physics in the United States. I mean, it's not India and Iran are examples of developing countries where there isn't this drop. And you could explain that in many different ways, but it's obviously possible, therefore, to have a culture, an economy, a society where men and women are equal in the sciences. So the real question is what needs to be, these are all good programs and good ideas. I think they're wonderful. And I encourage you all to join in this. But there are probably other good ideas as well.
Yes. I just have a comment. When you mentioned something about mathematics and physics, I think most students, I teach AP level physics, when they get into my class, the perception that they have is that when they think of physics, they think of math. And in AP Physics 1, it's not so now. It's more of reasoning ability. And since it's already stuck in the children's or in the student's brain that they have to do math, most of the time, the girls tend to shy away from the classes. And another thing is that I think it's also ingrained in some tradition that even from their family, that you're supposed to be, if they're female, if you're going to be, you have to go to medical field, you either become a nurse or a doctor. If you're a guy, you have to go to engineering, that's why you have to get physics. They don't see physics as also another way going into the medical field itself. They see chemistry and bio as going through to medical field. And I think it's ingrained in their head from the beginning.
Well, that's what's so great about this career in physics, examples of people in the medical professions.
Astronomy seems to have lots of women in it.
Lot will turn to a slot.
At the PhD level, the fraction of women getting astronomy degrees is higher than the fraction of women getting PhDs in physics. That is true. I don't ask me to explain it, but those are the numbers today.
So mathophobia is a problem, again, that is a serious problem. We're talking about physics, but math is also important, and there is this phenomena. Again, it's especially bad in the United States. Yeah.
If you look at one of the leading or most popular show that's on television, and this is supposed to represent our field, it is Big Bang Theory. The physicists that you have there are not women, okay? They're men, and they're not even persons that are underrepresented in areas. The females that you have there are, no disrespect, are biology and neuroscience, which in certain cultures they call that the soft of the science. So you create this hierarchy and of every day, and this is what we're feeding our kids all the time, because this is the leading thing that's going on. So we have to change the perspective, not only what's going on in the classroom, but what's going on in the outside industry.
Of course, culture, Hollywood, television. So, we once invited the producers of Big Bang Theory to come to the KTB, and we had a discussion with them. Indeed, the physicists there on Big Bang Theory are presented. They're white, male, etc. No diversity. And what bothered me even more is they were nerds. I mean, they gave totally the wrong impression of white male physicists. Anyway, we tried to convince them to, and we had a very interesting discussion, which ended with a little kind of exercise. We all had to write a plot for a TV show that we would try to sell to their producers, and they failed us on all attempts. But you're right. So you guys are on the front line with this issue, really, and you can help for sure. But we are battling against all sorts of biases and cultural norms and history, and it's a battle, but it's one worth fighting. So I think we don't have more time since lunch is getting cold. So let's thank Justin again and all of you.
Thank you.